Pete, I noticed you have something in your hand there.
It is the Lawnmower 3.0 from Manscaped. And I don't know if you know this about me. I'm not really a beard-wearing guy. I've obviously had this for the duration of since we've been doing the podcast, since, I guess it was June when we pretty much got a start on this season. But I've only been growing this beard because of the pandemic. I thought it was a great idea. Maybe I'll get a chance to grow a beard for the first time in my life.
Many COVID beards out there.
Yeah, and many people don't know me as a beard wearer, and I don't really know myself as a beard wearer.
And I've known you for many years, and you were never a beard wearer, and I was going to say something.
Yeah. Well, nobody really, I don't mind it. Nobody really likes it, I'm sure. And I've been smart enough to keep it trim because I got this Lawnmower 3.0. So all year I've been keeping it trim, but right now it looks a little bit fuzzy and
Time
gross.
to go, you think?
Yeah. So I was going to do this here and give you a show. I know because you have one of these things.
I have one, and honestly, it's the best. I mean, I've had products like that before. It is the best shaving product I've ever had. It's not even close.
So I was going to just trim myself up and maybe not show you, but show everybody else how good I'm going to look afterwards. So
but just to be clear, we will fast forward this, will we not?
Yeah, nobody wants to see this.
Okay, great.
Forgive me, because this is kind of gross. I'm ready to come back out here. Okay. All right. So I know this is disgusting.
Yeah, in retrospect, maybe take two, you throw down some paper towel, perhaps?
Yeah, I don't know if there's a take two now, but what do you think?
No, there's no question about the shaving quality. Yeah. And you were throwing it around there pretty loosey-goosey, not really seemingly worried about cutting yourself.
No, and you don't need to because it's got the patented blade where it's no nicks, is what they say about this here blade. I'll tell you, with Manscaped, it provides the best in men's grooming and hygiene, made only from the best products and ingredients for the modern man. And Manscaped has changed the grooming game with their Perfect Package 3.0 Essentials Kit. Now, this is a package that comes with the new and improved Lawnmower 3.0, the water-resistant cordless body trimmer, which you know about. Their advanced skin-safe technology and cutting-edge ceramic blade makes your trimming nick-free. So, and the kit includes an anti-chafing deodorant.
As opposed to a chafing deodorant. Nobody wants that.
No, or a chafing odorant.
Yes, nobody wants an odorant.
Yeah, it includes the anti-chafing deodorant and a moisturizer to help you feel and smell your best. Subscribers to what we call the Perfect Package 3.0 kit get new replacement blades delivered to their door every 3 months, and for a limited time you get not one, but 2 free gifts. So you get the Shed, which is a travel bag where you can put all your accoutrements in, and you get their patented high-performance anti-chafing Manscaped boxer briefs.
Yes, I'm wearing mine right now.
You probably are.
You'll have to take my word for it.
I'm just gonna have to take your word for it. You can get 20% off plus free shipping at manscaped.com when you use the promo code
What If?
That's right, all one word.
You still got something over here.
Do I? I'll fix this in the break. Let's get to the show.
The sun formed first, and then Jupiter formed out of the leftovers from the sun, and then everything else formed out of the leftovers from Jupiter. So in a really important sense, if I want to understand where did the Earth come from, I better start with where did Jupiter come from?
Wow, you really do clean up well.
Right? I feel so much better, so much lighter, and this is just feels right.
Not to be a hater on the beard, but this is the Pete I know and love.
Thank you. I hope everybody else loves it too.
How do you feel about a little game of solar system trivia today?
Solar system trivia. Well, why not?
Sweeping the nation.
I mean, if there's one thing I probably know a bit about is the solar system. Working at what if, half of our videos are set in space, so I could probably keep up.
You think you know your way around the solar system, do you?
I mean, yeah, enough. I can get there.
Okay, let's get cosmic. Start the insanity. Where is Earth in relation or proximity to the sun in the sort of order of planets? Where is it?
Well, this is Solar System 101. And actually, sorry, it wouldn't really be Solar System 101. I say that only because during the 2000s, it kept getting rammed in my head. This NBC promo, Thursdays... Watch.
I think it was must-see TV.
Third Rock from the Sun.
John Lithgow, Jane Curtin, Kristen Johnson, and of course a young JGL
who I think is a great actor.
Joseph Gordon-Levitt for the non-converts.
Right? We were just saying earlier, I really like that guy. I think he would be friends with us for some reason.
I would hope that he's a fan of the show. So yes, JGL, if you are listening.
JGL. Call us JGL.
Yes, we'd love to have you on. Okay, question number 2. What is the smallest planet today in our solar system?
Today. Well, I know where you're trying to lead me down in that pathway, but here's a little tidbit that maybe you do know, maybe you don't know. Ceres. A lot of people don't know Ceres. It's a dwarf planet, which would technically make it the smallest planet in the solar system, although it's not technically a planet. It's the largest body in the main asteroid field in between Mars and Jupiter.
Yet to be upgraded to planetary status.
Yet to be upgraded. So in that case, I would say Pluto, except for the fact that this is where you were trying to suck me in. Mm-hmm. Pluto was downgraded in 2006.
Bad day for Pluto.
Lost planet status, although there's still a lot of people around the world who are fighting for Pluto.
Yes.
Still, the smallest planet then becomes Mercury. And for bonus points, I'm going to tell you Mercury, just slightly larger than our moon.
Well, for showing off, you'll be deducted points. How is that? Next time, just answer the question. Protest. Finally, what is the largest planet in our solar system?
I think every schoolboy knows that's Jupiter.
And that is correct. And of course, most people do know that Jupiter is the biggest planet in the solar system, but not much more than that. So what if Jupiter never existed?
Well, I can tell you, I do know a lot about that. Normally, I wouldn't know a lot about something like that, but I did provide the voice for the What If video, What If Jupiter Never Existed. I can tell you a few things about it, but it'd probably be smarter for us to have a special guest that might be able to expound upon that.
Like maybe an astronomer from NASA?
Why not? Dr. Steve Levin received his PhD in physics from Berkeley in 1987. He began his career at NASA's Jet Propulsion Laboratory in 1990. He's the project scientist for NASA's JUNO mission. JUNO is a solar-powered spacecraft which has been orbiting Jupiter since July 4th, 2016. For a few hours every 53 days, JUNO passes within a few thousand kilometers of the giant planet and collects a wealth of new information about Jupiter. The data collected so far has revolutionized our understanding of Jupiter and of giant planets in general.
Great to have you with us, Dr. Levin. Thanks for joining us here today on What If Discussed.
My pleasure. Sounds like it's going to be fun.
Well, we're going to be talking Jupiter. And
that's fun.
We'll get to the bigger what if in a bit. But to be honest, Peter and I were talking sort of before you came on that, most people know that Jupiter's the biggest planet in the solar system.
11 times the size of Earth.
11 times the size of Earth. I think most people don't know that, but a good factoid. Mm-hmm. Some people might know that it's a gas giant. I didn't know for years that it was the 5th planet from the sun and that we're separated, Mars and then Jupiter, that close to Earth. But I mean, basically my point is relatively little common knowledge about Jupiter. It didn't feel like we'd been able to do much exploration. Well, the JUNO mission that obviously you're such a big part of has changed the game. How much have we learned about Jupiter since JUNO sort of left Earth in 2016?
So the phrase we like to use around the project is it's a whole new Jupiter. Basically, we sent JUNO to Jupiter to measure a bunch of things that hadn't been measured before, to try to peek beneath the clouds, right? Because even though Jupiter, as you said, is 11 times bigger than the Earth, that's the radius. So it means you could fit over 1,000 Earths inside it. It's the most massive planet in the solar system by far, more than twice the mass of all the others combined. And we've been studying it for hundreds of years. Galileo looked at it with his telescope hundreds of years ago. Even though we have all of that, mostly we didn't know what lay beneath the clouds. We'd look at Jupiter from the Earth and it's this giant atmosphere and it's covered with clouds. So we sent JUNO there to use gravity to measure what the interior looks like, to measure the magnetic field which comes from deep inside the planet, to use radio waves that can see through the clouds, to go over the poles of Jupiter for the first time, really, and take great pictures in the north and south where you can't see it from Earth because it's all in the same plane in the solar system. a whole bunch of new kinds of measurements, measuring particles in Jupiter's magnetic field, things like that. And essentially, everything we measured gave us a surprise. We were looking for, is there a dense core down in the center? And sure, we expected something between maybe 3 and 20 times the mass of the Earth down in the center. But what we found looks like maybe it's not a dense core with a sharp boundary. Maybe it's sort of fuzzy and it takes up like half the radius of the planet. We measured the magnetic field and it was way more complex than we expected it to be, with all these bumps and wiggles in it, and it doesn't look like a dipole like the Earth's field. And it's way different in the north than the south. We measured through the clouds with our radio receivers, and we found that the deep atmosphere doesn't get well mixed the way you'd expect. Everybody thought, get beneath the clouds and it's this giant ball of gas. It should be pretty much the same anywhere you look. Well, that's totally wrong. So we got surprises every single thing we took a look at. Even the pictures over the North and South Poles, it looks so different that the first time we looked at the pictures, a lot of the people in the room were saying, "Are you sure that's Jupiter?" It just didn't look at all like Jupiter looks like from the side.
And those pictures have been shared, right? And where can people find those pictures, just before I forget?
Yeah, so there's this great opportunity out there. So we have a website called Mission JUNO, missionjuno.swri.edu, but you can get to it from NASA's website or just Google Mission JUNO. And the JUNOCam images, that's the images from our visible light camera. Basically, we just dump the raw data out on the web and let anybody who wants to play with it, make their own pictures, fix up the colors, stitch things together, however much work you want to do, and post them. And we've gotten an amazing response. There's several people out there who are real power users who take that data and turn it into these amazing pictures beginning to end. There's a lot more people who take the intermediate steps and use those and try stretching the color, changing the contrast, or combining them to make movies and do some great things. People are doing science, people are doing art, people are making pretty pictures. It's really been fun.
Talk about that planet in relation to our planet. I don't know if everybody knows how much Jupiter may have affected Earth's development. Among other things, it's protected us from a lot of flying rocks, but what else?
Right, so the flying rocks thing is basically, if you imagine something drifting into the inner solar system, when it gets near Jupiter's orbit, Jupiter gravitationally is likely to perturb it, and a lot more of those get shot outward than get shot inward, so it can protect us. But more generally, just the formation of the whole solar system. When we look at how did planets form, which, by the way, is something scientists don't really understand all the details about, the most important models for how does the solar system form, how do we get the planets, indicate that Jupiter came first, not too surprising because it's the largest. It got there first, it got all the material, and then it affected the formation of the whole rest of the solar system. So there's lots of ways to think about that, but the one I like the best is if you just look at our solar system like you were an alien or something and don't know what's there, you'd come along, you'd see the sun, and you'd say, maybe that's it, that's all there is this star. And you'd be 99.5% right or something, because almost all the mass is in the sun. And then if you looked a little bit further and said, oh, wait, I see that speck, that's Jupiter, right? You'd be more than 2/3 right if you said that's all that's left, because Jupiter's more than 2/3 of the remaining mass. Well, the sun formed first, and then Jupiter formed out of the leftovers from the sun, and then everything else formed out of the leftovers from Jupiter. So in a really important sense, if I want to understand where did the Earth come from, I better start with where did Jupiter come from? Otherwise, I'm never going to get the picture.
So I guess the short answer to what if Jupiter never existed would be Earth wouldn't have existed, and I'm guessing the rest of the solar system wouldn't have existed?
Well, I love that question because it's actually way more complicated than it sounds. So imagine, when you asked me that question, the first thing I thought of is, okay, imagine Jupiter just didn't start to form. What would happen? Well, the answer there is probably one of the other planets would have gotten a whole lot bigger and sort of become like Jupiter. Because if you look at the other really big ones, it's Saturn and Uranus and Neptune. What we think most likely happened is as the planets formed, they drifted around because they're eating up the material that makes the initial cloud of gas and dust, and that changes their momentum, and so their orbits shift around. And those other planets probably came along after Jupiter was really big. Jupiter altered their orbits dramatically. Looks like it probably sent them outward away from the sun. And they didn't have as much stuff. Jupiter ate all the stuff first before they could get there. So if Jupiter wasn't there, well, maybe Saturn drifts in further and Saturn eats all the stuff and looks a whole lot like Jupiter does now. Of course, exactly where they ended up depends on all of that process. So if you take Jupiter out of the mix, you totally rearrange things. Maybe we get a giant planet close to the sun, or maybe we don't get a giant planet anywhere near the sun, and there's really big ones out far away, and we only have little planets close to the sun, or have 6 of them or 10 of them instead of 8 or 9. All of that would be different if Jupiter didn't form. And on top of that, well, if you say, okay, suppose Jupiter formed and we got all the planets in the right place, but now I'm gonna just reach in and pop Jupiter out of the picture and say, what happens? Then you get a totally different kind of answer, right? The other planets don't get perturbed that much anymore, but anything that's falling into the inner solar system, like comets and asteroids, mostly really small rocks, maybe you wouldn't call them asteroids, meteors, things like that, without Jupiter there, they don't get perturbed the same way. Their orbits are very different. Mars isn't big enough to do much of anything. So then you worry about, well, we get hit by comets more often, or if you pluck Jupiter out of the picture after everything formed, but before everything had settled down, then you get a different answer. Maybe the amount of water on the Earth might be different because Jupiter probably influenced that. So any step along in the process, if you don't have Jupiter, you get a different picture. But what picture you get depends on when you took Jupiter away.
It's funny because these days, you know, more people are talking about how interconnected things are here, how we have to be reminded that even though there's seemingly a lot of distance between us and the other side of the world, and in fact, everything has this sort of butterfly effect, if you will, and affects everything else. So it's interesting to see that that's the case. Obviously, the further we zoom out into the solar system as well. You mentioned smaller rocks, and these days, of course, the moons around Jupiter, I think, especially in this sort of astronomical circles, are getting as much attention, maybe even as Jupiter, especially Europa, Ganymede, etc. What has Juno been able to sort of glean more about Jupiter's moons?
Okay, so first I should say our most important job so far about Europa has been to stay the heck away from it. And that's because people are very excited about the fact that Europa appears to have a liquid water ocean underneath its icy surface, and maybe find life in that ocean. So picture 20, 30, 40, 50 years from now, you finally built a system that can do it, and you fly to Europa and you land on the ice and you dig down beneath the ice, and we don't know whether that's a few feet or a few hundred miles, but you dig through the ice, you get into the water, you sample the water, you find life, and then you have to say, but I don't know if that came from Europa or contamination from when Juno hit it 50 years ago. That would be a problem. So because we're there to study Jupiter, we have to be, and we didn't go through all the steps you do for, say, a Mars mission to make it as clean as possible and have no bacteria on it or anything like that, nothing that could survive. We have to show we're not going to contaminate Europa. And what we did at the beginning is we said, all right, well, we're there to study the main planet, not Europa. We'll just stay the heck away from it. However, we're coming near the end of our prime mission. We're writing, actually sending it in today, I think, an extended mission proposal to NASA to ask to keep giving us money to continue because the spacecraft's doing well and we have lots of great new science we can do. And part of that proposal, which of course NASA will have to decide if they have the money, part of that proposal is to study Europa because we think with our radio receivers that we use to look at the atmosphere, we can look at Europa and tell you something about maybe how thick the ice is and whether there's water near the surface. We have other instruments that, if we're lucky, maybe we'll see a plume and be able to tell something about whether Europa has geysers or not sticking out into space. We can look at all the other satellites, and I would not think of that as, assuming it gets funded, as a like prime mission that studies the satellites, because that's not what we were there for, and we're not geared to do everything you want to do to study Europa. But it's a great advanced scout mission for NASA's mission Europa Clipper or the European mission JUICE that want to go to Jupiter and study those moons and learn a lot more. We can learn a little bit that might help them refine where they do their measurements and what they do. We can measure some things that they weren't designed to measure because they're focused on stuff that was more Europa specific, and we have instruments that were really focused on Jupiter, so we measure slightly different things. There's lots of great stuff we can do if NASA decides that they want to fund our extended mission or has the money to fund the extended mission. And
wow.
if it includes Europa.
Some breaking news here on What If discussed.
Yeah. To say that this is the golden age of space exploration would be an understatement. We talked about the JUNO mission. NASA launched a probe to Mars earlier this year. We got the announcement last week, and we had a guest on talking about the possibility of phosphine on Venus and what that might spur in terms of further exploration. What is it like to be working at NASA these days?
I got to say, it's really fun. I mean, I've been working for NASA one way or the other for about 30 years. And it's always been fun because we're exploring. We're trying to figure out things where nobody knows the answer. But right now, we're getting close to some really important answers. We're learning, it's in my lifetime, in my career as a scientist, is at the beginning of my career, nobody had discovered any planets around any other star besides our own. Now it's practically routine. Oh, they found another planet around some other star. And it's only interesting if it's a special case, if it's more Earth-like, or it's really close to its star or really far from its star, or things like that. We're getting distributions of that. We're learning how many planets there are typically in our own solar system. We're learning about different ways to look for life within our own solar system, and we're getting further along doing it. Our robots have gotten so good that we can launch robotic spacecraft and do these exploration things that, when I was growing up, I thought only, you'd have to have people there to do. And of course, it's way easier to send a robot than it is to send a person, mostly because the robot doesn't care if you give it a ride home. So all of that, it's really a great time to be doing space exploration.
Yeah, and I mean, with the way the world is these days, I know Peter and I have experienced this before, that when we get to talk to people like yourself that, help us zoom out and remind us that the world isn't our little navel gazing day to day, that there's just obviously so much beyond this planet, so much to look forward to, and even so much to be optimistic about the future versus all the dystopian sci-fi and post-apocalyptic stuff. I think we see a lot. It's easy to forget that. So this is great. Can you stick around and talk? You mentioned some of those exoplanets and kind of future NASA missions. Can you stick around for a bit?
Sure.
So we are going to take a break with Dr. Levin right now, and he will be part of the extended audio podcast. Exactly. Which you can find, I guess, if you're watching YouTube, the link is where, Peter?
Listen, if you're watching this on YouTube right now, you want to click on the link and you'll get the extended audio version of the podcast, and we can hear the rest of the conversation with Dr. Levin. But if that's all the time you have for us today, then well, that's fine too. You're going to stick around because we're still going to do a little video chat after this, and then we'll check in on part 2 later.
But Peter and I will sort of sum up our takeaways from the first half. Where can people, you mentioned the website for the footage from the JUNO mission. Where can people find that again? And where can people follow your work?
So the easiest thing for people to remember is if you go to NASA's website and search for JUNO, you'll find all of this stuff with links to everything. But the main JUNO website is a site called Mission JUNO. So it's missionjuno.swri.edu. And if you just Google Mission JUNO, you'll find it. Or if you do a web search for JUNOCam, you'll find us. It's pretty easy. Just so long as you got NASA or Jupiter or something in there to keep from getting confused with all the other JUNOs out there.
Like the JUNO Awards up here in Canada. Which
Google will get you there, basically.
Which honor the best of Canadian music. You don't want, that's an entirely different JUNO.
You might want to see that.
Yes, Dr. Levin will.
Do want that site too. It's pretty interesting.
I think Alanis Morissette won a JUNO back in the day as Alanis, but that's a story for another. What if? Okay, Dr. Levin, sit tight. We'll be back with you in a sec. And Peter and I will be back to sort of sum up our takeaways from our conversation with Dr. Levin about the JUNO mission and what if Jupiter never existed.
Cool.
So I guess like Dr. Levin and the people at the Jet Propulsion Laboratory with NASA, they learned stuff. We learned stuff. They learned that some of the things that they had assumed or known about Jupiter turned out not to be true or were at least more than they had expected, of course, because they got to finally actually look at it from a
quality pictures, digging
digging
deeper. So they got to go beneath the gas surface and see what's happening down there.
Had some assumptions about it, but in fact were, I think, happily proven wrong.
I like when NASA does some things like that and we find out about it and we can bring it to the viewers. It's almost that fast.
Well, in this particular case, you're having some real-time learning going on because, again, he's giving us the sort of the backstory as to what they learned at the time, and then we're learning that. And to your point, then people listening or watching are learning. I learned also that we have this sort of big brother, big sister relationship with Jupiter on Earth, right? It's been essentially shielding us, protecting us for all this time. And I had never, honestly, before, I know it sounds stupid maybe, but I'd never thought that all that space debris and asteroids coming in this direction would have naturally potentially hit us if we weren't kind of protected from that side.
Well, you know what I thought was interesting was that if Jupiter, he gave us an idea of how the universe was formed. Jupiter obviously was, or not obviously, we learned today, or I learned today, it was the second object in the solar system. And if it hadn't been there, or if it wasn't there, there's a possibility Earth wouldn't be here either.
Yeah, so it's not a small relationship we have with Jupiter. And what if Jupiter never existed? As it turns out, again, as we sort of put it out there, if Jupiter never existed, there's the possibility that Earth never existed. But he also added a bit of a sort of a caveat to that whoever else would have been there, they might have gotten, let's say, the leftover mass.
Yeah.
So maybe in a different scenario, Earth would have been the size of Jupiter, and instead of having 7 billion people here, we'd have 700 billion people here.
Or maybe it wouldn't have stayed in the habitable zone, or maybe it would have gotten too big and there wouldn't have been enough water on it to sustain life. There would have been a whole host of other reasons why maybe life didn't exist, never came to be on Earth.
You know what it sounds like to me, Peter?
Sounds like a story for another What If. Well, if you want to hear more of our conversation with NASA's Steve Levin and you're watching the video podcast on YouTube, well, what you're going to do is click on the link below and it will take you to the extended audio version. Now, some of you are listening already on the audio podcast. There's no link for you. Don't look for anything.
Just stay tuned.
No. So join us on the other side. We'll talk more about life on other planets and
space exploration and a whole bunch of other cool stuff.
Europa. And if that's all the time you have for us today, well, thanks for watching. You can join us next week when we talk about the mysteries of the octopus with the director of the film, My Octopus Teacher. You won't see an octopus in the same light ever again.
No, they're fascinating. That's why that movie has blown up on Netflix, My Octopus Teacher. And it'll be really cool to get some insight. What If has done a couple of octopus or pie videos.
Octopuses.
But this is going to be a really cool conversation.
Right. That's next week on What If Discussed.